expressing my appreciation for the opportunity to speak here. Hopefully, I'm able to shed some light on some things that maybe you weren't aware of. Special thanks to the Oklahoma Geological Survey, and I'll also offer, thanks to the Moore Norman Technology Center here. It was actually at the Business Development Center, their incubator across the parking lot, that was our first office. So it was a little nostalgic coming back here. So I appreciate the opportunity and the invite. So I've titled it "Lessons Learned from our prospect." Again, it's in Southern Oklahoma, and hopefully, at least at a high level, I can introduce you to the concept of exploring brines and oilfield brines for lithium. So what we'll kind of go through today, first I'll give a kind of a brief summary of who we are, kind of how we got started, and where I think we're headed. Although I'm not an economist, by trade, hopefully I can give you at least a high level indication of what's going on kind of in the lithium space. An actual overview of the prospect itself, then kind of the importance, especially in today's climate, that ESG has in your operations and moving forward into the future. We'll touch a little bit on the technology, some of the DLEs that are out there and how they're performing. And then hopefully I can wrap it up with, a summary of the, some of the lessons we've learned as we've gone through this the past 3 or 4 years. So starting off with who we are, well, we're a energy exploration and development company. Again, out of OKC or more, kind of right there on the boundary there. But we look to identify and target sources of energy, to kind of help push the U.S. forward into the towards at least some degree or if not all a full degree of energy independence. Currently, like I said, our primary target is lithium in oil field brines, and we want to try to challenge the what would be the widely at this point accepted notion that that we have to rely on other nations for our supply of these elements like lithium. We're a combination of geologists, hydrologists, GIS experts, and landmen, and we look at the mineral content in basin brines and kind of the extraction thereof. And I believe that our skill sets lend themselves, to excel in this area. And I'll touch a little bit on that here in a minute. We're not necessarily mining people, but this is about fluids that are deep in the basin, and the value that's in those fluids. So the skill sets that we develop as oil and gas, geologists and professionals, it does cross over into the space. And again, all of that while focusing on a positive and strong ESG mining message instead of solutions. I'll just kind of say briefly on a side note, this Friday we're receiving the Keep Oklahoma Beautiful's Environmental Excellence Vanguard Award. So that's a bit of a tongue twister. And then that'll put us up for the Keep America Beautiful Award going into next year. But we'll start with, why lithium? Well, I think one of the first lessons that we had to learn as a company is, and how we kind of came about this was that we had to identify a strong and sustainable market going into the future. And in doing this, we kind of, like I mentioned earlier, we realized that there would be a future in energy for petroleum geologists from the oil and gas field. We were kind of inspired by the shale gas revolution, that when you rely on other companies for your imports, you kind of subject yourself to those geopolitical issues that can arise from time to time. So we had to find a way to choose kind of the right market at the right time. Hope you don't mind if I use my cheat sheets here. So, but what's this about? Well, it's about batteries, obviously, but just like a tank of fuel stores energy, a battery stores energy, and the lithium in this case is about the batteries. And these batteries are everywhere. It's not just EVs. Although the market or the political forces, can sometimes be leaning or feel like they're definitely leaning towards an eventual transition into vehicles that produce less of these greenhouse gases. For instance, Tesla, they clearly haven't let up on their production over the past few years. You got Volkswagen, who has pledged $100 billion to build out their global EV portfolio. Toyota, $70 billion, and 3.5 million EVs by 2030. Ford with a $50 billion pledge and 3 million EVs by 2030. And the list goes on. Mercedes-Benz for 47 billion, BMW for 35 billion. But the point is, these companies, they are headed that direction. Even natural market forces are driving them that direction. And people can argue or politicize whether we need these EVs in this revolution or not. But nobody's arguing over the fact that every one of us have these electronics in our pockets and these laptops out on the table, and and we've become completely dependent on them. And not only that, but who wants the electrical blackouts or brownouts, for instance, like Texas had last year during the ice storms. There's been a recent huge push for on-demand power, especially at the household level. And sure, there's generators, and they've always been and will probably always be around. But like we're seeing on the East Coast today, we're having these fuel and diesel shortages, and that just lends itself to more issues. So having a power wall in that, for instance, a power wall at your house to kind of have that on-demand and supplemental energy could alleviate a lot of these issues. But again, a battery is just storage and mobility. It's agnostic to the energy source you put into it. It doesn't matter if it's nuclear, hydro, wind, coal. It doesn't matter. It's just storing the energy. And so I don't think it should really be a politicized issue. Even every American has phones, all your tools that you have out in your shed, at least the majority, and I'm still trying to get there, are operated by batteries. Toys, laptops, everything's got it. And so what is the future? Well, the future is an ever-growing demand for portable electronics. And although we see massive increases in energy sources, and we will see massive energy increases in sources like wind and solar, these sources, this was mentioned earlier, they're not always a constant supply. You need the ability to store this issue for those off-peak hours when the wind's not blowing or the sun's not shining. But I mean, obviously the elephant in the room is that EVs will be, still a large factor moving forward. So that's going to bring me into, kind of a little bit of talking about the supply and demand here. What we've got right now, the yellow here, this is through 2040. This is our operational supply with a couple different types of projections. But you can see even with just the possible additional tonnages added to the supply chain, we don't even come close to meeting it as things stand right now. And as the world moves towards electrification, so too does the need to store that energy. Only 6 years ago, rechargeable batteries accounted for about 42% of the on-demand, or 42% of the demand for LCE, or lithium carbonate equivalent. By 2026, that percent will jump to around 86% or higher. And as it stands with historical methods of production, we don't really stand a chance of meeting that growing demand. By 2030, demand for lithium, will outpace supply by about 1.75 million tons. And according to the International Energy Agency's 2021, the world's lithium production of about 345,000 tons of LCE will need to increase by over 40 times to keep pace by 2040 with their sustainable development scenario. So what does this demand mean for price? Well, I think we can all imagine what that's going to mean. On the right side here, we see things like cobalt and nickel. And although they are crucial for the battery production, and I think we'll hear about that in a talk or two, and they have increased, they're not, you can see that they're clearly not behaving in the same fashion as lithium. Lithium is going to be the key to these batteries. We've seen a 600% increase in the US since 2020. And even on the left side of this chart here, we're coming off of a bubble right there in 2018. But even since then, we've seen roughly 350% increase in price since before COVID hit. Even during COVID and during all the lockdowns and such, companies like Tesla, they didn't slow down on their production, which is part of what's led us to the situation today. And aside from production, kind of what are some of the other key aspects that might affect the price? Well, current supply chain. Supply chain is kind of a buzzword at the moment. But the US, as you can see here, it only produces about 2.6% of the lithium. Now, I believe it's even lower than that, but we'll move on. And we see that the overwhelming majority of this lithium is funneled through China in some way or form. 80% of battery materials are processed in China. And the US is already a 15% consumer, and that's probably well on its way to 25 at this point. Oops, sorry. The movement, around the globe of all the shipping, it kind of negates that ESG message I was talking about earlier. What you gain from lithium, you're going to lose, not all, but a sizable portion of it with all these greenhouse gases that are emitted. The carbon footprint of this shipping, it's significant. An average shipping vessel will burn through about 63,000 gallons of marine fuel per day. But what about the US's demand? Well, what we have here is are all the locations of the US EV and lithium battery plants. You can see that they aren't really focused along the West Coast or in and around Silicon Valley like you might expect. Rather, they're actually concentrated now more on the East Coast. And this is for a variety of reasons, some being favorable regulations or tax incentives or whatever you might say, but the point is they are. And part of this is because the US implemented really a top-down approach. That started with the manufacturers. That sure, they wanted to build in the US, but the supply is still coming from China. The infrastructure bill that was recently passed, due to it, for EV makers, there are restrictions on getting the tax break on an EV unless it is not only sourced or not only built, but primarily sourced in the US or a country that we have a trade agreement with. Notably, China is not one of those. So in terms of supply, well, here we have the current and or proposed lithium supplies in the US. Most of these are in the western half of the US. And this includes predominantly, geothermal brines, or spodumene or hard rock mines. But something that we keyed in on when looking at the different options is we wanted something that was geographically favorable to the current demand. And so what's just the star there in Arkansas, that's where our prospect is located. And that geographic location plays an important role, or it played an important role in our evaluation. And being centrally located in the US and much closer to the majority of these gigafactories in the US, we believe our South Arkansas prospect is positioned nicely, with available rail and other modes of transport to supply this ever-growing demand. Excuse me. So what about the Smackover? I'm sure many of you are probably familiar with this. It's a well-known formation. It's been a prolific oil producer for many years. We're targeting, or the Smackover that we're targeting, it spreads pretty much the majority of the Gulf Coast. And even though the Smackover formation extends the majority of the Gulf Coast, there are these, isolated hotspots of different elements, and it's not just lithium, but in our case, it is lithium. And these different hotspots as it relates to concentrations. But the brines that we're targeting is looking at the bottom picture here, bottom left picture, they're mainly found in these oolitic shoals that contain a great deal of both, porosity and permeability. Average porosities of roughly 8%, upwards of 15%, and permeability that's reaching to the Darcy level in many cases. And not only that, but we, at least within our prospect, we have an average concentration of lithium about 325 parts per million. And so therefore we'd require much less volume than others would across the US. And also we won't experience a lot of the complications associated with things like high temperatures, for instance, like those lithium are the geothermal lithium brines. We don't have some of the silica issues associated with those. Although the Smackover is better known for its historical oil and gas production, today it produces half of the world's bromine from a brine reservoir that was once rich in oil, and but now it's obviously becoming known for its abundance in lithium. In terms of our operations, right there in green, like I said, there's an existing bromine trend in here, and this is going to play an important role. But there's an existing bromine trend in here, and we offset that. We're adjacent to Albemarle that you see there in red, and their bromine production operation. Albemarle and Lanxess, them two together, they produce about half of the global supply of bromine. Important or not, that they were not the original. They did not actually put this together originally. Companies like Dow Chem, Great Lakes, and Ethel Corp did, but these companies came in and bought these positions up. To our north is Tetra. Tetra is an oil field chemical producer. The area that is leased, or that area is leased by what is currently the only lithium producer in the area, and that's Standard Lithium. You might have heard about them. And they have eventual plans to develop that blue Tetra acreage there. But as it stands, they have a commercial scale operation, currently finishing up development that utilizes the tail brine over east of us on the Lanxess's bromine operations. But after we did, an extensive review of the data, combined with our geologic interpretations, we realized that there was still meat on the bone and opportunity here for us to come in and capitalize on. Again, I believe our expertise, not only in the petroleum background, but kind of in our knowledge of leasing and how that works, allowed us to quickly be able to initiate not only the exploration, but the leasing operations. We originally targeted 200 million parts per million. That's kind of our cutoff, 200 and above, obviously. And but then we later extended it beyond that because we do want to have disposal areas in our asset here. This prospect, it's 120,000 acres, and it's positioned pretty much precisely over the lithium-rich region of those oil field brines, and it's the most lithium-rich oil field brine found to date. And we've collected a lot of data in and around this region concerning chemical data, concentrations, and it is pretty well concentric right here. Like I said, there's these hot spots that occur, concentric and localized, and it was able to be delineated and mapped out. And there is, especially around outside of any of the operators here, there's a kind of a background value of anywhere between 50 to 100 parts per million. But at the depths we're talking about here, those don't really offer any economic opportunity. They're not going to be viable, at least as things stand now. They're learning this up north in areas like Canada. But based on our, what is essentially our internal modeling, to be economic, you'll need around 300 to 500 parts per million. Now, that's not standard operations, but at least if you're going to start up, and build $500 million plant, drill wells, pipelines, things like that, you're going to have tons of OpEx that you're going to need to offset. And it's going to depend on the ROI you want, honestly. But that was kind of the number we set. And like I said, it was kind of due to our background, we just kind of treated this like a land rush. We came in, identified the area, and made the area that made the most sense to us economically, and we took advantage of that. And the reason I keep saying that is because there isn't much overlap really between the mining industry and oil and gas as it relates to procuring assets like this. They don't really understand the urgency that you need to have whenever you're going after something like this. So we're able to leverage kind of our understanding of leasing with urgency to go in and procure our operational area. Moving into what's my favorite part, we got into the actual geomodeling, and this was kind of my contribution to the company. And like I said, the beauty of this process that sets it aside from many other prospects out there is that we're able to use these tested and proven methods that have been established in the oil and gas industry for years. You know, by utilizing methods that were developed in the oil and gas world, combined with the chemical data, the historical chemical data that was available, we were able to focus in and delineate, you know, kind of the most prolific parts of this reservoir. We're able to gather data that was readily available, you know, things such as your locations, your logs, your bottom hole temperatures, your field studies, things like that, and use those in creation of these geomodels. You know, detailed structure maps and high density geocellular models were produced, and this helped guide our understanding of the nature of this reservoir. Pore volumes as well as elemental tonnages can not only be calculated but visualized, and this would help also guide our drilling program and recompletion program. Not only that, but I mean, it did help drive our leasing efforts. That was part of the decision to go ahead and extend and have our disposal areas also. So I think, you know, one of the important things we realized here is that the regulatory rules for mining, though, still govern this part of the energy sector. You know, a driver for having this model, and now we have to call it a resource, because instead of you know, what we typically say is a reserve, you know, it's referred to as a resource estimation because, well, the regulations for reporting them for the mining industry is to do such. The rules are designed kind of more for solid phase mining prospects and not necessarily the liquid phase. 7 minutes, sorry. You know, I thought I was going to fall short here. I'll keep going. But it's based on, you know, regulations for reporting to the SEC, and these drilling and recompletion efforts are because your data for your reports has to come from within your prospect. You can't use outside or data that's outside of your leased area. I won't go into much detail, but you know, in terms of who owns the brine, well, one of the good things about where we're at is they do separate your oil and gas minerals from brine and other elements. So that helped us when we moved into these areas of established oil field production. Like I said, this is favorable in our case because this legislation has been fleshed out since the 50s, whenever this bromine production had started way back when. So they've had plenty of time to, you know, kind of nail in and get it exactly where they want it. Well, like I mentioned, we went on next with our formation testing, and we, you know, initially we worked from the historical data that was available, but we knew it was important to first prove up our prospect. And fortunately, like I said, all the technology and expertise that was required is already available in this area. It's an existing oil field. Most of the former Smackover producing wells in the area, you know, had since been recompleted up whole. But by understanding the reservoir, we were able to dial in and focus on what wells we wanted to recomplete. Went in, recompleted them, and got the tests that we want. And able to gain that valuable concentration data that we needed to confirm what the historical data was suggesting. You know, not only or this doing these recompletions, you know, boosted our confidence enough that we then went out and were able to drill an infill for data. And you know, at that point, especially in the heart of our area, we tested 500 plus parts per million. And remember, like I said earlier, you need we figure you need about 300 plus to be economical in a startup. Not only that, but we filled numerous totes full of these fluids, those 270 gallon IVC totes. We filled a ton of these as pictured here. And we're able to send these to extraction companies, you know, these different technologies to allow them to test their brine, test their processes to real life examples of brine. That's something that they lacked, was real life examples of these brines. And we did this in an effort not only to gain knowledge for ourselves, but to help expedite the role that they're going to have to play in meeting this demand that's only growing. I'll just kind of, I won't spend much time on this now, but this is kind of a list of the prospects that are available out there. But what makes us so special? Well, as you can see, as it relates to the tonnage, which is the LCE in metric tons there, as well as the concentration, we pretty well dwarf all other North American brine prospects, not only in concentration, but in tonnage to be extracted. You know, this coupled with the fact that we don't have those complications, like I mentioned, of the geothermals out west or the concentration issues up north, which I'll get into more detail in just in a slide or two. Quickly though, I want to, you know, in terms of ESG, let's look at some pictures here. These are all to the same scale. You know, you got the mile down there, but what you have here is you have South American salars on the left. You got Australian open pit mining's in the middle. Then you have what is a full-scale bromine facility here in southern Arkansas. You know, you've got these miles and miles of evaporation ponds. Might have lost my spot here, but sorry. Anyhow, you got these miles and miles of evaporation ponds that are not only creating the environmental hazard, but the impacts on wildlife and such. Open pit mines, same thing can be said. Not only that, but then you got the massive mounds of tailings that you got to deal with after you've played this resource out. And like I said, ESG, it's become an important component in what people are looking for now in terms of mining lithium. Skip through that. Moving on to the actual technology itself. So this is a very simplified diagram, but like one of the positive aspects of this is what you take out of the ground, you put right back in. You pull out what you're looking for, but then it goes right back into the same formation. So the yellow lines there, you're going to take your spent brine and you're going to send it right back to formation. Now then, you'll have your DLEs, which is the gray box, and that'll give you your lithium chlorides, at a concentrated form. And then there's other processes to take where you can get to lithium carbonate, or lithium hydroxide. And here's kind of a more detailed, and this isn't even really an exhaustive list or a diagram, but there are other steps associated. But again, the key thing is this is a closed loop system. What makes our brine special for this? Well, we kind of consider it to be what would be like a Goldilocks brine, so to speak. Because temperature, it correlates to kinetics. And I've mentioned this a couple times before, as I was going through this talk. In the case of the salars in South America, the brine temperature is around 10 degrees Celsius or 50 degrees Fahrenheit. It's got to be heated to 80 or 90 degrees Celsius, or 175 to 195 Fahrenheit for the DLE to work off, proficiently. On the other hand, you got the geothermal lithium projects like those on the in the southern California Salton Sea. And we see these brine temperatures around 250 degrees Celsius, or roughly 500 Fahrenheit. Well, those projects like that are going on in the Salton Sea, this high, this high water temperature has a very destructive nature on not only the equipment, but you got things like the high silica content and lower concentrations that are just really posing challenges for these places. Yeah, so hopefully you had enough time to look at that one. But anyhow, in terms of technologies as it relates to us, though, and these are some recent publications that have came out, but we were able to partner with IBAT, International Battery Materials, and we were able to run a sizable pilot, and they were able to use our brine, and with very positive results coming from this. Not only that, but so here's a picture. This is kind of their facilities that we were able to run it through. But what this has proved really is that the DLE can be commercially viable for these oil field brines. So kind of wrapping up here, what are some of the lessons that we've learned? Well, first, the petroleum industry, we have the experience and the technology to explore for these subsurface brines. There is a strong and sustainable market as it relates to lithium out there, and I think that we in the oil and gas industry have the proficiency and the expertise to go out there and get it. These domestic resources can be found. There's more out there. There are favorable regulatory environments out there for brine leasing, and that mining resource estimations, and regulations do apply to this space. And finally, ESG is obviously an important consideration moving forward, into this new era of energy. But also that these lithium technology, the LCEs, the DLEs, the direct lithium extraction technologies are evolving, and they are getting there. And that's the important part. And they're evolving with companies like us. Like I said, we've evaluated quite multiple of these, and several have passed with flying colors, while others might have somewhat crashed and burned. But every technology does require its own parameters. That's kind of what I was getting at when I was talking about the different, makeups of the brines over there. But what do we do next? Well, there are going to be more resources like this out there, and this is where we'll have to this is where it will be up to us geologists to use our skills available to go out and find them. And these will be the resources that are going to drive us into the future. I appreciate the time. Hopefully I've been able to say something that's been able to at least give you a little bit of information on it, and I'll turn it over.